My dear friends, today I'll be talking, in this video I'll be talking about quadratic equations, and I'll be starting from the point I stopped the last. Then take this question today the first. We want to show the roots of this equation are real. Show the roots of the equation these are real. Now, the theory I did to you in the last video is that when you consider the equation a not equal to 0, ax square plus bx plus c is equal to 0. The necessary condition for the roots to be real is b square minus 4ac larger than or equal to 0. Using this theory, we'll try to handle this question. Is a b minus c x square b c minus ax c times a minus b is equal to 0. Now you got to show that the roots of this equation are real. You got to show that the roots of this equation are real. Now we would compare this equation with the theory. Now look here. This certain part of expression acts as A, this certain part of expression acts as B, this certain part of expression acts as C. Now, we've got to take the delta, the discriminator, b square minus 4ac, and then b would be this value, b times c minus a, b square minus 4ac minus 4 times a would be this a b minus c, and c would be this value c a minus b. b square minus 4ac. Now we got to show that this is a plus value. We'll try to expand this and get into a situation to show that this is a plus value. Look here. This squared, you get b square. C minus a square would be c square minus 2ac plus a square minus 4ac, then b into a, b into minus b square, c into a minus c into minus b plus cb. Now we want to show that this is a plus value. Try to expand it more. You get b square c square minus 2b square ac plus b square a square, that is a square b square, minus 4ac multiplied by ba, it would be 4a square bc minus into minus plus 4b square ac, minus into minus is plus 4. These two values multiplied, you get AC would be a square c square Minus 4ac into b would be minus 4 times c into c would be c square, and then you get ab. Now, we want to show that this expression is plus. We want to show that this expression is plus. Any value to show is plus. You can show it a complete square or as a total of squares. When it becomes a square is a plus value. When it's square is a plus value. We don't know how we would get this by simplifying. Let's say I take this complete square b square c square. I just undersign so that we'll not miss. Then I would get this a square b square b square, complete square. Then I would take this 4ac, 4a square c square. The values I took, I undermarked. You get minus b square 2ac plus 4b square ac. It would give 2b square ac. You get 2b square ac. Then the remaining values would be minus 4a square bc, this value, and this minus 4c square ab. Now, to show that this is a plus value, look here. You know that a plus b square, this from grade 9 mathematics, you get a plus b square is a square plus 2ab plus b square. Then a plus b plus c square. Now, if you get at least a small difficulty in the understanding, do please go to the video I did, the first video on quadratics, and then come into this. Because I did similar easy question at the last of the last video. Then, you know that a plus b plus c square is a square plus b square plus c square plus 2ab plus 2ab, 2ac and 2bc. Try to get this sort of picture here. I would, from b square c square, I would take bc. From a square b square, I would take ab, the complete root. For a square c square, I would take the complete root to ac. Even though you write plus here or minus here, when squaring it will be plus. Even though you write plus or minus here, when squaring it will be plus. Even though you write plus or minus, when squaring it will be plus. You got to get 2b square ac. If I put plus here, then these two multiplied and multiplied by 2 would be 2b square ac. Since the other two values are minus, I'll try minus here. These two multiplied, 2 into 2 minus 4 a square bc minus 4a square bc. These two multiplied, you get minus 2 into 2, 4c square ab, 4c square ab. Therefore, this would be plus. B square minus 4ac would be plus. Now, for the roots to be real, b square minus 4ac has to be larger than or equal to 0. Can this be equal to 0? We'll just try. We put the equal mark and then we will say then we would say delta is equal to 0 when delta would be 0 if this complete part is equal to 0. When BC plus AB, BC plus AB, BC plus AB minus 2AC is equal to 0. It would be BC plus AB is equal to 2AC. B common C plus A, B common C plus A would be 2AC. B would be 2AC divided by C plus A. Now delta can be 0. Now if you are new to the subject, you may ask me, if it's BC plus AB minus 2AC is equal to 0, can't we make something like this? You may ask me, AB is equal to 2AC, going to the other side, BC minus, then B is equal to 2AC minus BC divided by A. You may ask me, can't we take a condition like this? No, you can't. For the reason, when B is made the answer, within the answer there can't be a value B. When B is made the answer, within the answer there can't be a value B. Now in this certain situation, B being made the answer, being the answer, no B values here. Now you can say therefore delta larger than or equal to 0. Therefore the roots of the above equation are real. You write, then the roots of the above equation are real. Roots of the above equation are real. Now let's say, I'll try to talk a little more about this question, the mathematics behind this question, right like this. In the former question it was, or as in this question it was, in this question it is A times B minus C x square plus B times C minus A x A C times A minus B is equal to 0. Look carefully. The question comes into A, B, C. It starts from A, B minus C x square. A, B minus C x square. Then you get B, C minus A x. Then you get C, A minus B. The question was written starting from A. If you are making a note, write underneath. The question could be written starting from B. B, now, is as such I explained to you in the last video, it's circularly symmetric. Then if you start from here, B, C minus A x square, B, then you come to C, C, A minus B, x. Then you come to this point, A, B minus C is equal to 0. We can also rewrite the question starting from A. Then you get A times B minus C x square. Then you go to B, B times C minus A x plus B times, then you start from C, C times A minus B. These are the same question, but not really the same, something different, same form, same model. I did this question now in this video. You try for homework, you try these two questions. Then, the next topic I have to talk to you is that combinations of roots in a quadratic equation. Now, the next topic would be combinations of roots in a quadratic equation. Say, if the roots of the quadratic equation, if the roots of the quadratic equation are not equal to 0, ax square plus bx plus c is equal to 0 are alpha comma beta. But look here. Now, if the roots of this certain equation are alpha comma beta, if I divide this equation, complete equation, by a, x square plus b over ax plus c over a is equal to 0, also has the roots alpha comma beta. Now look here. When you divide this expression by a, since you divided by a, you got to say that a not equal to 0. If the roots of this equation are alpha beta, divided by a also has to be alpha beta. If you are new to the subject, you may think of how did it happen. Look here. You go to O-level mathematics. Think of 2x square minus 6x plus 4 is equal to 0, and you are asked to find the roots of this equation. Grade 9 mathematics. What is the first step? Now you want to find the roots of this equation. The first step is that you completely divide the equation by 2. You get x square minus 3x plus 2 is equal to 0. You put this into factors. X, 1, 2, minus is equal to 0. And you say the roots are x is equal to 1 or x is equal to 2. Now look here, you were to find the roots of this equation, but you divide it by 2, it's the same roots, divide by a value. That logic is brought in here. Divide by a is, it has the same roots. Let this be equation number 1. The equation whose roots are alpha and beta is equation whose roots are alpha and beta is, now look here. In this certain situation, the equation whose roots are 1 and 2 was x minus 1, x minus 2. Then the equation whose roots are alpha and beta would be x minus alpha, x minus beta. I take that logic here. The equation whose roots are alpha, beta is x minus alpha, x minus beta is equal to 0. Then simplifying, you get x square minus alpha x. This simplified, you get minus alpha x. These two multiplied, you get minus beta x. We can write them together, minus common alpha plus beta times x minus alpha minus beta multiplied alpha beta is equal to 0, 2. Now look here. This certain equation, the roots were alpha beta. This certain equation, the roots are alpha beta. The equation 1 and equation 2 both have the same roots alpha beta. Since the roots are the same, the two equations have to be same. Since the roots are same, the two equations have to be same. Comparing coefficients, then comparing coefficients, the coefficient here is 1, the coefficient is 1. Since these two coefficients are equal, the other coefficients also have to be equal. Then it has to be minus alpha plus beta is equal to the coefficient of x. Minus alpha plus beta has to be equal to the coefficient of x here is b over a. Then you get alpha plus beta is equal to the minus going to the other side, minus b over a. And then the constant value here has to be equal to the constant value here. Alpha beta is equal to c over a. Now, if we are to summarize all what is done in this certain situation, we can say a not equal to 0, a not equal to 0, ax square plus bx plus c is equal to 0 when roots are alpha and beta. Alpha plus beta is equal to minus b over a. Alpha beta is equal to c over a. You got to keep this in memory. Alpha plus beta is equal to minus b over a. Alpha beta is equal to c over a. You got to keep this in mind. Alpha plus beta is equal to minus b over a. Alpha beta is equal to c over a. Now we are talking of combinations of roots in a quadratic equation. We are talking of combinations of roots in a quadratic equation. Now, we took alpha plus beta and alpha beta. Then say 1. We can find the value of alpha square plus beta square. Alpha square plus beta square. Now look here. Alpha plus beta, the complete thing squared is equal to alpha square plus 2 alpha beta plus beta square. Then, keeping alpha square plus beta square here, this could be brought to this side. Then you get alpha plus beta complete thing square minus 2 alpha beta. alpha square plus beta square is equal to alpha plus beta complete thing square minus 2 alpha beta. Since I was handling this for the first time, I explained like this, but when you get used to the subject, you can write at once that alpha square plus beta square. You consider alpha plus beta square. Alpha plus beta square. What you get? Alpha square plus 2 alpha beta plus beta square. That 2 alpha beta you get extra other than this. Then you subtract this. Subtract the middle value 2 alpha beta. When you are used to the subject, not necessary to write this. You can write this at once. Then it would be, look here, alpha plus beta is minus b over a. Alpha plus beta is minus b over a. Complete thing square minus 2 times alpha beta is c over a. Alpha beta is c over a, is 2 times c over a. Then you get is equal to minus squared, you get plus b square over a square minus 2c over a is alpha square plus beta square. Then 2, we would say we can find alpha to power 4 plus beta to power 4. Now look here, alpha to power 4 plus beta to power 4. Observing this expression, you can write alpha 4, you take the complete root alpha square, beta to power 4, you take the complete root beta square, and then you square it. Alpha square squared, you get alpha 4, beta squared, you get beta 4, and the middle value you get 2 alpha square, beta square. It's not here, therefore I would write 2 alpha square beta square. Then it would be alpha square beta square was this. I would substitute it here. It was b square over a square minus 2c over a complete thing square minus 2 alpha square beta square. Alpha beta was c over a, then alpha square beta square would be, this part also gets squared, c square over a square. This is alpha 4 plus beta 4. Now, in the same manner, we would say that we can find alpha square beta square was this. We can find, there is a third theory, we can find alpha to power 8 plus beta to power 8. Alpha square beta square, 2 into 2 is 4, alpha 4 beta 4, 4 into 2 is 8, alpha 8 beta 8. We get alpha to power 8 plus beta to power 8 is equal to, when alpha to power 8, you take the complete root of it, alpha 4, beta to power 8, you can get the complete root of it, beta 4, complete thing square. Now look here, when this is squared, you get alpha 8, this is squared, you get beta 8, but more than that, you get a value, the middle value, 2 alpha 4 beta 4, where is not here. Then I would say minus 2 alpha 4 beta 4. Then it would be alpha 4 plus beta 4 is this part of expression. It is b square minus a square minus 2c over a complete thing square minus 2c square over a square. This alpha 4 plus beta 4 I put here, I substituted here, complete thing square minus 2 alpha 4 beta 4. Look here, alpha beta is c over a, you put into the power 4 this side also you got to put into power 4, it would be c4 plus a4. In the same manner, we can keep on finding the values. 2 into 8, alpha 16 plus beta 16, alpha 32 plus beta 32, alpha 64, beta 64. If need, we can create theories. And then the next combination of roots in the quadratic equation, it would be 1, 3, 4. We can find alpha 3 plus beta 3. We can find alpha 3 plus beta 3. Now look here. To find alpha 3 plus beta 3, again I would take you to the time you were studying O levels. You know that A3 plus B3, the factors, it was said factors of total of 2 cubes. Total of 2 cubes, A3 plus B3. I'm making you to remember the O-level mathematics. Look here. When is A3, we took A. When is plus, we took plus here. B3, you took B. Then it was the first, you write the second expression. Observing this, you square this. Multiply this 2 and change the value, square this, b square. If your memory in your O-level mathematics is faint, you take it now, you get it now. A3 plus B3, A3 you put A here, B3 the third cube plus, you put plus, you write the second factor, observing the first. Square this, multiply, change the sign, b square. Beware of, is not 2ab, is minus ab. Then, you get alpha 3 plus beta 3 is equal to, alpha 3, you take the value alpha, beta 3, you take beta, and the second factor is written observing the first factor. You square the first value, multiply, change the sign, and square the second value. Then you get alpha plus beta from here is minus b over a. Alpha square plus beta square was, alpha square plus beta square was b square minus a square minus 2c over a, minus alpha beta, again alpha beta was taken here, it was c over a. Alpha beta was c over a. Then you get is equal to minus b over a, b square over a square minus 3c over a. Now when you find alpha 3 plus beta 3, The next value you can find would be, we can find the value of alpha 6 plus beta 6. That is, alpha 6 plus beta 6 would be, take the root of this alpha 3, take the square root of this beta 3 and you square beta 3, you square. Alpha 3 squared you get alpha 6, beta 3 squared you get beta 6, and the middle value to be subtracted. 3 alpha 3, 2 alpha 3 beta 3, middle value 2 alpha 3 beta 3 is subtracted. Then simplifying this, when this squared you get alpha 6 plus beta 6, the middle value is subtracted. Then again, for alpha 3 plus beta 3, you can substitute this is minus b over a, b square over a square minus 3c over a. Complete thing squared minus 2 alpha 3 beta 3. Look here, alpha beta is c over a, alpha 3 beta 3 is c3 over a3. Now, the logic can go on as such. Alpha 6 beta 6, you can find the value of alpha 12 plus beta 12. You can find the value of alpha 24, beta 24, and as such. Now, if you are a good sort of in a mental situation, good mind, good thinking power, you may ask me, can't we find values like alpha 5 plus beta 5, alpha 6 beta 6 found, alpha 7 plus beta 7? Of course we can find, and there will be some more other form of theory to find this, where I'll be doing in future videos. Now, the combinations of roots in a quadratic equation, then the next value would be, we can find alpha minus beta. We can find alpha minus beta. We use a theory like this. We compare the values alpha minus beta square and alpha plus beta square. Look here, when alpha minus beta is squared, you got alpha square, you will get alpha square plus beta square minus 2 alpha beta. If this is being squared, you get alpha square plus beta square plus 2 alpha beta. Now you do tell me please, if these are to be made equal, what is the value we got to subtract from this? What value subtracted from this? The two values would be equal. Look here, alpha square beta square common is plus 2 alpha beta here, then minus 2 alpha beta. Now, before I write, you guess what you got to write here. 2 alpha beta has to be removed and another minus 2 alpha beta. That is, you got to get 4 alpha beta. 2 alpha beta minus 4 alpha beta, you get minus 2 alpha beta. This is alpha minus beta square. Then you get alpha plus beta was minus b over a square minus 4 times alpha beta here is c, alpha plus beta minus b over a, alpha beta c over a. then it would be minus squared plus b square over a square minus 4c over a. That is alpha minus beta square. There's alpha minus beta square. What we got to find is alpha minus beta. Then we would say, taking the square root of this, alpha minus beta is equal to square root. Alpha minus beta, taking the square root of this, you got to get square root b square over a square minus 4c over a. And surely you know that when taken the square root, you got to put plus or minus. Now, what else we can find? What other combinations we can find? Combinations of roots in the quadratic equation. Look here. Then the next would be, we can find, I can stop somewhere here and go to the next section. But it's my policy in life for the last 45 years, if I do teach a section, I do it completely, so that your knowledge is complete. We can find alpha square minus beta square. Look here. Alpha square minus beta square would be the difference of two squares. It would be alpha minus beta, alpha plus beta. We have just found the value of alpha minus beta here. You substitute it here, you get plus or minus square root b square over a square minus 4c over a, and then alpha plus beta is minus b over a. Alpha plus beta is minus b over a. Then look here, you get a plus or minus here and a minus here. What would you get when plus or minus and minus multiplied? If this minus gets multiplied by this minus, you get a plus value. If this plus gets multiplied with by this minus, you get a minus value. Then you get b over a, square root b square over a square minus 4c over a. And then you may ask me, any other combinations of alpha and beta to be found? Look here, alpha minus beta was here. Now in a question, sometimes in a short question, you may ask to find the value alpha 3 minus beta 3. We can find alpha 3 minus beta 3. At once, if you asked this question, sometimes you may get confused. Therefore, it's my part to teach all what could be questioned in an exam. For a short question, this could be asked to find alpha 3 minus beta 3. Look here, alpha 3 minus beta 3, the difference of two cubes. A little before I took the total of two cubes, A3 plus B3 was A3 plus B3 was, when it was A3 here, I took the value A. When it was plus, what I did a little before. B3, you take B, you write the second factor observing the first factor. You square this, multiply, change the sign, B square. Now in the same manner, A3 minus B3. A3, you take A. When it was plus, you put plus here. When it was minus, you put minus here. Then you, as such before, you write the second factor observing this, square the first value. Multiply, change the sign. When you multiply is minus AB, change the sign, it will be plus AB, and you square this. Then, putting this into factors, it would be alpha 3, you take alpha, minus, you put minus, beta 3, you take beta, and the second factor is written observing the first factor. Alpha square, multiply and change the sign, then you get beta square. Then you get beta square. Alpha minus beta, we found a little before, plus or minus square root b square over a square minus 4c over a. Then alpha square plus beta square, these two values. It was alpha square plus beta square was b square over a square minus 2c over a. And you got a plus alpha beta plus alpha beta plus alpha beta was c over a. Alpha beta was c over a plus c over a. C over a. Then you get plus or minus square root b square over a square minus 4ca, and here you get b square over a square minus 2ca plus ca would be minus c over a. Minus c over a. And now the next we would go to another question using these combinations of roots in a quadratic equation. Now the question says that if the roots of the equation x square plus 7x minus 3 are alpha and beta, you got to show that alpha 3 plus beta 3 plus 7 times alpha square beta square minus 3 times alpha plus beta is equal to 0. We'll handle the question like this. X square plus 7x minus 3 is equal to 0. When roots are alpha comma beta, when roots are alpha comma beta, you get alpha plus beta is equal to, look here, alpha plus beta is equal to minus b over a. Then alpha plus beta is equal to minus b over a is 1 here, is minus 7 over 1. Alpha beta is equal to, alpha beta is equal to c over a, c over a. Then here alpha beta would be minus 3 over 1. Minus 3 over 1. Now, to handle the question, you need the values of alpha square plus beta square and alpha 3 plus beta 3. We get alpha square plus beta square. From your knowledge you got in the early of the video is, can you remember what is it? Alpha square plus beta square. You take a piece of paper and try to write what it is. Alpha square plus beta square. Could you? Can you remember? It was alpha plus beta complete thing square minus 2 alpha beta. Alpha plus beta was minus 7 complete thing square minus 2 alpha beta. Alpha beta is minus 3. 7 squared 49 minus into minus plus 6 is equal to 55. Then we'll try to get the value of alpha 3 plus beta 3. Can you remember the factorization? The total of two cubes, alpha 3, you get alpha, plus you get plus, beta 3, you get beta here. And the second factor is written observing the first factor. Second factor is written observing the first factor. That is, you square this, multiply, change the sign, and you square this. Then you get alpha plus beta is minus 7. Alpha square plus beta square, we found just a little before, it was 55. 55 minus alpha beta was minus 3. Then you get minus 7 into 58. Then you'd get 7 into 8, 56, 5 remaining, 7 into 5, 35, with the 5 you get 406. Then we'll try to enter to this equation. Say, then we get this expression, to take it, alpha 3 plus beta 3 plus 7 times alpha square plus beta square minus 3 alpha plus beta is equal to, alpha 3 plus beta 3 was 406. Plus 7 times alpha square plus beta square, it was 55. Now it was alpha plus beta into this, alpha plus beta was minus 7, this was 55, multiplied, it was minus 406. Then this would be minus 406 plus 7 into 55 minus 3 times alpha plus beta was minus b over a, alpha plus beta was minus b over a, that was minus 7 over 1. This is minus 406. Seven into 5, 35, 3 remaining, 7 into 5, 35, 38, minus into minus, plus 21. 285 plus 21, it is minus 406 plus 604 is equal to 0, Now, for homework, I'll give a similar question for you to handle. It would be, if the roots of the equation x square minus 5x plus 7 is equal to 0. If the roots of the equation x square minus 5x plus 7 is equal to 0, show that alpha 4 plus beta 4 minus 5 times alpha 3 plus beta 3, alpha 3 plus beta 3 plus 7 times alpha square plus beta square is equal to 0. From this point, I would go to the next video. The next video, I would consider more difficult questions and at the end of this video I'll be handling the most difficult questions which had been in the past papers. I would do in class. I do in this video now. For now, I'll stop. If you think that you got this subject completely, do please subscribe my channel and also click the bell icon so that as soon as I put a video, you'll get it faster. Then for now, I'll stop. Thank you very much.